Hello and welcome. Today we'll talk about overlay networks. We'll start with a brief overview of the stack. So we'll start with just a basic data center concept. You've got hardware. On that you have operating systems and applications. In a data center, you own and operate all of your own infrastructure. A virtualized data center just allows virtual infrastructure and virtual machines that run operating systems and applications. Once you rent from cloud infrastructure as a service, you have a limit of access, control, and visibility. So you get hardware and provider virtual infrastructure from your service provider, and then on top of that, you can build your own virtual machines. If you move up the stack a little bit to platform as a service, you can then rent services and build and host your apps running on those platforms. Things like serverless and AWS Lambda are kind of in this area. Software as a service, you rent everything under the line of access, control, and visibility, and you just get a web UI or user interface. So that's things like web-based CRM, Slack. So then to put that stack in a network example, start again with the physical layer. So in London, that's your physical routers, firewalls, and switches. And over in Chicago, it's a private data center, private networks, physical servers. They both connect through the public internet to Amazon's public cloud physical infrastructure. So that's the data center's walls and physical server racks that Amazon owns. And then in the virtual layer is Amazon's infrastructure as a service. So these are their virtual compute offerings, so EC2, S3, things like that. And then on top of that, you can build the application layer. So here on EC2, we have some example applications. Just a quick refresh on Amazon's shared responsibility model. This is from Amazon, and they emphasize that AWS is responsible for security of the cloud. So that's the physical data center, compute storage, databases. And then everything above that line is security in the cloud that you, the customer, are responsible for. So we're talking networks today. So that means things like network traffic encryption, firewall configuration, IAM. So these are things that AWS provides, but you, the customer, are responsible for. So Amazon has firewall, but you have to go and configure them. Same thing with IAM. So here again is that limit of access, control, and visibility. So it's a clear delineation between AWS and you, the customer. So here's that line in our little network diagram. And overlay networks can help you with that limit of access, control, and visibility. So here's an overlay network. It simply is a network over the top of all the underlying infrastructure. So with an overlay network, you can create a network that you can access, control, and view. And with the right settings and configurations, you can seal it, make it completely separate. The biggest part of an overlay network is that it separates identity from location. Some other basic concepts are that traffic stays on the native or physical layers, so it relies on those devices that Amazon has, but you can separate it and do things like control your own IP addresses and layer over the top of the native layer. So an overlay network is simple and separate. Just a quick overview of how an overlay network works. You start from your data center and connect through to things like switches, firewalls, and routers. Then you go over the public internet and connect to Amazon's private edge. From there, you're in the virtual layer with a virtual private cloud, VPC. You can pick a region availability zone and spin up an instance. On top of this, then you have that limit of access, control, and visibility, where you can build your own app and build your own overlay network that you can control and manage. From there, you can connect down to customers, other cloud regions, anything like that. And the great thing about an overlay network is that it looks this easy. And if you build it correctly, you can create high availability failover so that all that matters is that you are connected and there's a cloud involved. So why use an overlay network? Well, it's simple and separate. You can also limit access to your cipher suites and keys. What we mean by this is that traditionally you might share a pre-shared key, but if you're in a multi-tenant environment, like a public cloud, you might want to lock that down for security purposes. You can also use higher rates of encryption like AES 256 or 3DES on top of things that Amazon offers. For example, Amazon only allows AES 128-bit encryption. An overlay network also allows you to connect multiple availability zones, regions, and even other cloud providers. You can also enable multicast and similar other protocols. So we use multicast because it's disabled in Amazon and most other multi-tenant environments. Some enterprises use it to connect many-to-one types of communication. So if you need to connect to an enterprise that uses multicast in their networks, you can enable it in a cloud-based overlay network. You can connect subnets and IPsec endpoints that use the same IPsec range. So we talk about beware the default subnet. So here both London and Chicago have used VPC in US East 1 and went with the default subnet 10.0.0.0/24 or 16. The problem is that you can't connect or peer with the same overlapping IP ranges, or say you need consecutive IP range. In the overlay network, you can create a completely different logical subnet. So here in this example, we used a logical subnet of 172.31.1.0/32, and then assigned each application its own consecutive IP address. An overlay lets you connect a VPN to a specific endpoint public IP across regions without using extra gateways or adding additional costs to AWS or your cloud. Similarly, you can use the overlay network to connect multiple IPsec endpoint tunnels, IPsec tunnels. AWS only allows one edge device per VPC. With an overlay, you can open up IPsec edge device connections to as many as you like. Here we've got 4 IPsec tunnels to 3 different locations, but they're all separate and distinct from one another. If you need to do things like compliance or monitor your network traffic. In an overlay network, you can also use IPsec over NAT-Traversal. So for example, London needs native IPsec, but Chicago prefers to use IPsec over NAT-T. You can connect into the same overlay network. Even though AWS and most cloud providers only support native IPsec, you can enable them side to side. Plus, you only have to pay for a virtual machine, not IPsec and NAT services in addition. You can monitor your network separate from the provider if you use an overlay network. In an overlay, you can use SNMP, or Single Network Management Protocol. You could also dump traffic from a network interface to your own logging and debugging. So in this example, you can use Amazon's CloudTrail for analytics, but you can also use things like Datadog or Splunk and use them all together. And finally, you can use an overlay network to add reliability without performance sacrifices. In this diagram, we've got an overlay network spread across AWS and Azure, and we have the same range of overlay IPs. Control of your overlay is independent from provider. You can add network connectivity and reliability for multiple regions, and things like built-in disaster recovery or failover. Next, let's talk about overlay networks with VNS3. VNS3 is your cloud network solution. It's a software-only virtual appliance. It acts like a virtual router, switch, firewall, VPN concentrator, protocol distributor, and extensible NFV. Because VNS3 is software, it can run in any virtualized environment, and it runs alongside applications to provide additional network security and connectivity. VNS3 helps you enable things like a partner customer network, cloud VPN. It can help you connect to rapid dev test environments in cloud. You can use it for failover and disaster recovery, and add security and compliance components to your cloud. We have 3 main VNS3 products and 2 plugins. All of our products are useful for things like scalable VPN. It adds end-to-end encryption, and you can create multi-cloud, multi-region environments. You can use the management system or high availability plugin to add network monitoring and management, and automatic instance-based failover. So here, back to our network diagram example, here's an overlay network built using VNS3. We have our London and Chicago locations again connecting over the public cloud, but through secure IPsec tunnels. Those connect into a single VNS3 controller, which acts as a router, switch, firewall to connect all of those applications in AWS, but in a separate, sealed, isolated overlay network. Now let's add some complexity. Here's a cloud overlay networking diagram. We also jokingly call this our sexy diagram because it is pretty complicated, but we like to show off all the things that you can do with VNS3, even in this small screen. Here we've got a single overlay network built across Amazon with 2 VPC regions and an Azure VLAN. We have 2 locations, one in Seattle, Washington, and one in London. They're connected via 3 VNS3 controllers that have 3 separate public IP addresses that connect through both a public and private IP address for connectivity, and those connect through our cloud-based applications. Using VNS3 overlay networking, we've created a separate VNS3 subnet, 172.31.1.0/24. And then we've assigned each app its own IP address. So we have 4 applications in AWS and a backup database in Azure. And then on controller 1, we have VNS3HA, that little arrow around the VNS3 symbol. So that is automatic instance-based failover to 2 more peered controllers in the mesh. We also have 2 failover IPsec tunnels that connect the 2 data centers and 3 VNS3 controllers. So a little bit more about overlay high availability using VNS3. Back to our single VNS3 overlay network. This is one option to use a overlay network. If you peer 2 VNS3 controllers, you can do instant backup by just switching from one controller to another. You can also configure them so that if one VNS3 controller fails or the region fails, you can do automatic instance-based failover so that your 2 IPsec tunnels immediately switch over to your backup controller, which then connects to your overlay applications. We also have the option for BGP Active IPsec failover. Similar scenario, but we use BGP tunnels. And with VNS3 MS and HA, you can do automatic failover for all the VNS3 controllers in your management network. Next up, we'll talk about real-life overlay network use cases using VNS3. Our first customer is Gizio. They're a North American financial management solution company. They provide PCI compliant SaaS for banks and credit unions in the US and Canada. They are unique because they're completely AWS based. So all of their databases and servers live in AWS. They've spread it over multiple VPC regions for higher availability, and they use a multi-tenant overlay network to connect their AWS resources to multiple customers. The thing that really matters to Gizio are the IPsec tunnels that connect their AWS resources to multiple customers through multiple IPsec tunnels through just a handful of VNS3 controllers. VNS3 is able to keep those IPsec tunnels separate and distinct to help them stay PCI compliant and manage that financial data. Using VNS3, they grew from 1 customer in AWS to more than 400. Also in financial services, we have PayNearMe. They're a new payment processing company. Using VNS3 and AWS, they've built a loosely coupled infrastructure. So over on the left is their overlay network with their normal resources for DevOps and production. And then over towards the right of the diagram is their resource network with disaster recovery. So they use AWS for database replication failover, and then connect it all and group it together in logical subnets and segmented resources using VNS3. Trek 10 is an AWS and Cohesive Networks partner. They're an SI that helps people with existing IT infrastructure move to AWS. Whenever there's a security component, they always recommend VNS3. So this diagram is kind of an example use case. They have customers over to the far right that use an overlay network in a single VPC region to create a sealed, separate network. Even though it's in a multi-tenant shared environment, the overlay network helps them secure and control their resources in the cloud. Customer 2 in the middle uses 2 peered VNS3 controllers with failover IPsec tunnels. In their overlay network, they allow multicast between their servers and databases. And then over on the left, customer 1 is a basic cloud VPN use case. One VNS3 controller connects via IPsec tunnel to their customer and AWS resources. Our final overlay network customer is a US software vendor. They sell ERP and CRM software. Originally, before they were a SaaS solution, they installed hardware in their customers' data centers, but then they moved their resources to AWS. They used VNS3 to help them migrate, separate, and connect their resources to their customers, along with their existing data center. So for example, at the top, customer 1 uses an overlay network with VNS3 HA for high availability failover. And then at the bottom, there's their existing data center that they connect to their Amazon resources using VNS3 with VNS3 MS management. So through the management system, they can control and view all the other VNS3 devices that connect to their customers. They can do things like easily upgrade and manage all of the VNS3 devices in their network. Thanks for watching, and if you have any questions, you can email us at support@cohesive.net. I also recommend that you check out our VNS3 HA demo. It walks through that high availability automatic failover using VNS3 HA and MS. Also check out all the videos on our YouTube channel. Thanks.